All right, so today we're going to be learning about exponential growth and decay functions. So here we have two different exponential functions. I know that they're exponential functions because both of them have exponents of x. Now we are going to determine which one is growth and which one is decay. But we're going to first start by identifying the different parts of each. So in my left equation, we have y equals 49 times 1.06 to the x power. So the very first thing I see here is 49. 49 is going to be our initial value. It is where the equation is starting, and it would be our starting point on our graph. Okay, so let's go over to this equation. Y equals -3 times 0.92 to the x power. So our starting point here would be our -3, and you can have a negative as a starting value. Okay, so in all exponential functions, you will always have an initial value, and that's always going to be your first number. Okay, next we have numbers that are inside our parentheses. So noticing the first one, inside my parentheses, I have a 1.06. So I'm going to write 1.06. Now this is going to be our factor that we're changing by. But there's two things we have to keep in mind, okay? If it is greater than 1, it is going to be growth. All right, so in this case, I have 1.06. So if that was $1.06, that would mean I'd have more than $1. So this is what we would call a growth factor. Okay, that is how we identify if it's growth or decay. So right away, I'm going to put up here that this is a growth problem because it is greater than 1. All right, so let's look at the right side now. I look inside my parentheses, and we have 0.92. Now, if I was again to think about that like money, 92 cents would not be the same thing as having a whole dollar. So this is what we would call a decay factor. Decay means decrease. So it is less than 1. So that is decay. And up here, I'm going to write nice and big, decay. So again, I know it's decay because it's less than the number 1. All right, so there's one more thing we have to figure out, and that is going to be our rate at which we are changing. All right, so the way we're going to figure that out is we're going to pay attention to this 1.06 number, but I'm going to say to myself, if I had the number 1, okay, just like we're here, this is greater than 1. So if I had the number 1, what would I have to add to the number 1 to get 1.06? Hopefully you would say, well, if I had 1 and I needed 1.06, I would add 0.06. So this is our rate. Now I'm also going to write that as a percentage. So 0.06 as a percent is just 6%. Okay, so let's go over here to the right side and do the same thing. All right, again, we're going to think about the number 1. Now since this was decay, this is less than the number 1. So this time we have to think 1 minus what equals 0.92. So now this one's a little, we have to actually use our brain. Maybe we need a calculator. Okay, another way you can think about it is just doing 100 minus 92. And that would give us 8. So our rate is 0.08, and our percent is just 8%. I know it's 8% because I just did 100 minus 92, I got right? And that would be the same thing here. 1 minus 0.08 would equal 0.982. So just a recap, okay? Growth of an exponential function, you are going to have a number inside the parentheses that is greater than 1. When you have a decay, the number inside the parentheses is going to be less than 1, okay? However, the things that they have in common, they're always going to have an initial value, and it's always going to be your first number. You're always going to have a number inside the parentheses, okay? And that's always going to be your factor. Depending whether it's growth or decay, depends on where it is above or less than 1, okay? And you will always have a rate.